Hi guys, it's me, Fox. I would like to start a new video series called Epic Upgrade, where I'm gonna be upgrading pretty much everything on that CNC machine. I'm gonna leave the granite frame and the spindle because those two things are perfect, and I'm gonna be replacing rails, ball screws, all the mountings, steppers with servos, controller, what else, new case because after the upgrade that won't be big enough, table, like I'm gonna pretty much build a new CNC machine, and I was like considering should I get more granite and build another one or upgrade this one. And the thing is, I don't really want to keep that machine in pieces where I need to mill stuff, so I will try to make it as painless as possible, or where I have a really minimal amount of downtime. So who knows, maybe I will have to make a completely new machine, but I'll try to avoid it. So I'm gonna be making parts on that machine for this machine. So let's take a look for some things I'm gonna be upgrading. I'm gonna be upgrading my cheap Chinese linear rails, which have ball carriages, with proper ones, which are slightly bigger, and they're called linear roller guides, and they're that big. So I think the carriage itself weighs 3 something kilograms, almost 4. So that's the comparison. Pretty much no difference. Yep. And you might think I'm insane, but I'm assure you I'm not. I'm just a little bit crazy. And let's take a look on the rest of the stuff. Here I have some stuff I'm gonna be replacing, and I want to give a special thanks to Tom from Motioncontrolproducts and everyone there who was involved into sending me the 4 servo CNC kit. They also have 3-axis servo kit for those who don't need 4 servos. They also have harmonic gearbox, which I'm definitely gonna give it a go eventually. I definitely want to add 4th axis into my machine. Perhaps I'm gonna make 5. It's a quite of a coincidence because I was like day from buying closed loop stepper motors, and I got a message from Tom asking if I would like to have this 4 servo CNC kit. And I thought, like, I couldn't believe it. Is he joking or something? And of course I want to have them and I want to test them, so thanks to them I will never have to upgrade the motors. And then I got the brand new Bosch Rexroth 45 size linear roller guides with roller blocks. Same, brand new, and they're precision grade with the preload of 0.13 C. And they have this metal cover, and you screw them from the back. And yeah, I think the bolts are every 5 centimeters or 50 millimeters. And I'm thinking to use 2 of those on my x-axis, and I'm gonna cut that one in half for my y. And I think on the x-axis I'm gonna use only 2 carriages, like one here, and the spindle in between. that might change, but I'm trying to fight some weight. What else? Why I went with something so huge? The one thing is that I wanted to have a spindle slightly higher, so that's the bonus, you know, of something so huge versus this. So that's the, you know, the difference in height. So that looks like extra 4 centimeters on, you know, of a Z clearance. And the other thing would be that bigger rails are more rigid, and the other thing is that those are roller guides, not the ball bearings, which is like the cream of the creams. So they're the most rigid rails and the most precise, with the minimal vibrations. Those ones vibrating like crazy, that one is pretty solid. What else? And then I'm getting new controller, and that's the, let me see what it is. CNC drive UC 300 Ethernet. CNC drive motion control. I got it from Polgardi Design. I don't know, some shop in Europe, with the breakup board. I'm not sure if it's the final controller, but I will give it a go. Maybe I'm gonna talk some more about the servos and some differences between servo steppers and closed loop steppers. Now I would like to say something about those three motors. That's the regular stepper, that's the closed loop stepper, that's why you have encoder here, and that's the servo. So regular stepper can go to 1000 RPMs, and that's the limit, really. I don't even think it can go to 1000 RPM and have any torque. It just 1000 RPM, it's a free spinning, and it has no power. As soon as you touch it, it just stalls. Closed loop stepper can go to 3000 RPMs, but again, at 3000 RPMs you touch it and it's dead. But it can go faster, and it's quieter and slightly smoother. Servo can go to 3000 RPMs with the full torque. So I wouldn't recommend to grab it at 3000 RPMs. Actually, don't grab any of them at 3000 RPMs. You might kind of, you know, damage yourself. But so that's the one thing, one difference between them. The other one is servo can spin freely, and the steppers have steps. And the regular stepper, I just want to check if I have any cables connected, but nope, all loose. They're much harder to turn, and they have the vibrations. And to show you the vibrations, I have an app which I used for my spindle test, and I'm gonna put the phone on top of the first, that's the regular stepper motor, and I'm gonna be turning the shaft, and you can see the EEG on what's going on. All right, so that's the regular, that's the closed loop. It's not much different, but I can rotate it easier, and it feels smoother and more quiet. and that one spins like this. There is nothing. And I'm gonna I'll take my mic and put it on the first stepper, so you can hear the like drum kind of thing. And I'm rotating this one, and that one is shaking. Now the closed loop, much smoother. And now the servo. There shouldn't be any sound. Yep. What I'm fighting for is that the steppers, because they have steps, they leave. It's very similar to turntable and records. When the records have the grooves, and they record the records by vibrations and the needle. So those things will produce the same kind of surface finish as the record in the turntable. Because of those vibrations, you have those vibrations embedded into the surface. With the servo, I'm hoping to not have that, because it rotates so smooth that that will be no problem with it. The same comes to linear rails and ball screws. Whatever vibrations they produce, it's embedded into the finish of the thing you're milling. So that's why I wasn't very happy with ordering closed loop steppers, because it's still a stepper, it still have those steps, much less than a regular stepper, but it's still there, and it would bother me, till the day I die. And thanks to Tom, I got those servos, and I'm super happy, because I know I can't put the blame on a servo. Here are my two rails. This is the old one, and this is a new one. This one, it's 20 millimeter wide ball bearing carriage, and the ball bearings are going on this surface here, this groove, and on the other side this groove and that groove. And the carriage looks like this. So you have balls in here which go like this. So the one row on the top and another row on the bottom. So, and the balls are recirculating around here and here. And the same it's on the other side. 2 rows of them. And the balls are like this. So they're pretty tiny. Where in this, it's using rollers, which are much bigger, and they have much bigger contact surface. And the same thing, the rollers are on the bottom here, and in here, if I can get the camera kind of right angle. Oh yeah. So yeah, and they're recirculating like this and like this, and again both sides, that side and that side. And there are going on this surface and this surface, and on the other side obviously, but it's too heavy, so I'm gonna be rotating it. So the idea behind rollers is that they have much bigger contact surface than those tiny balls, right? Because they touching the rail on the whole surface here, or like the very tiny portion of the arc, but the contact is from here to here. Where balls, the first thing is that it's much easier to make a cylinder, a precise cylinder of this size, than precise ball, because the ball has to be identical from every direction, right, to be precise. So, and it's smaller. So, so I would like to draw the difference in the precision and the size. So precision versus size. So you have, let's say, big diameter ball, let's say, and you have a small diameter ball. And if you have like 5 microns here, some imperfection, right? On the big ball, the effect on the rolling on the surface will be much smaller than 5 microns, which I'm gonna try to do kind of same size on the smaller ball. When that ball gonna hit that, you know, imperfection here, it's gonna be big jump. And here it won't be as much because of the, you know, contact surface here, and here it's like, you know, much bigger. Then the other thing is that with the rollers, when you have a roller, right? Roller is like this, you know, something like that. And let's say you have imperfect spot here, imperfect there. When it's rolling on the surface, those low spots are not affecting the smoothness of the travel, because it still has, you know, perfect, you know, surfaces here, right? So those low spots won't affect the, you know, won't vibrate. When you have a sphere or ball, you know, which is, you know, completely rounded, the contact point is just in this very tiny spot. And any imperfections or irregularities of that ball would affect the travel, so it would be jumpy. And obviously in the carriage you have, you know, plenty of balls, right? They could have all, you know, ups and downs here and there, but it's still, so it's averaging the imperfections, but they're still there. And when the one is going out, you know, recirculating back in, and when it comes in the contact, it usually vibrates, or when it leaves. So if that ball is bigger, then it, you know, the whole carriage goes down or up when it comes back. With the rollers, you know, that effect it's spread along this whole edge here, where the ball is just a point. So I hope that that drawing kind of explains some more about why I went with such a big thing. It's not for the strength, it's just for more precision. So here you can see the roller from the Rexroth on the rail, and you can see I'm shining the light from the back, so you can see if there are any gaps under the roller, and there are not. And now I'm gonna show you the difference with the ball bearings. So here I have a ball bearing on old rail, and you can see the contact surface for that one. It's minimal. And it depends on the rail. In some of the rails, it will be that the ball is contacting on this edge, somewhere here and here, because the groove it's not, you know, it's not matching the sphere. So it could be all sorts of strange ways. But yeah, you can see that here, the contact point, it's tiny. I know you know, if it's preloaded, it's supposed to fill the gap, but it's not. You know how hard it is to make this thing whoops, precise, just as the groove, right? I hope it all makes sense. It's like only thing which I'm asking is to just use the common sense, really. There is one thing which kind of drives me nuts when I see the reviews of linear rails, is that people say that they get the rail and they say, wow, that goes smooth and it glides. And you know, when the carriage is going smoothly back and forth and really like you can slide it off, it means that according to them it's a great rail. No, actually it means that it's a rail without the preload, or actually the block without the preload. And when you can slide it easily back and forth, you know, and that one is preloaded. It's not heavy preload, but it is preloaded, so it doesn't slide off that easy. According to them, it means that it's, you know, amazing because it goes so smooth. But in reality, is that that block will wobble this way, and that way, because it's so loose that it can slide off. And for example, that's why, like, you can get the same block with the preload of 0.8 C, and this block becomes precision or normal. I don't really remember exact terminology, but with the preload of 0.13, it could be this block is precision, and then you have super precise and ultra precise, but all of them are with the preload of 0.13 C. So you can't, you know, wobble it this or that. There is some kind of wobble in the documentation, but under a load of a ton or something, and it's like few microns, 4 or something. And yeah, that one slides much harder than this, you know. That one I can, you know, flick it. And that one, I can't really flick it. But it travels smooth, you know. It's not greased yet, but I hope you're getting the idea. Here I made the testing jig. I'm using my vices in a CNC, which are connected to the granite surface plate. I'm gonna measure the precision of, you know, cheap Chinese rail versus the Rexroth precision. On my previous videos, I did the same jig for testing, or similar. So I'm mounting a block to a vise and then I'm sliding the rail. And some of you had lots of problems with it. And I want to emphasize that that's the best way of measuring the rail, because otherwise, if you want to measure the carriage, you would have to bolt that whole rail to something super flat and then do the measurements according to the flatness of the surface you bolted it into. And that thing, it's really hard to obtain with the hole patterns and pressures and stuff like that, because all the rails are bowed. So end of the discussion. And you can only measure the way how it travels in a carriage versus the bottom surface of the rail, because that's the part of the rail which is mounted to, in theory, the flat surface. So let's do the test. Pin the jig, the carriage in a vise, dial indicator, it's dialed and it's marking the rail. Nothing loose, right? So now I'm gonna slide the rail back and forth so you can see that's what, 30 microns. We go that way. So there is a 20 here, then it dumps to 0, then it goes back to 30. Or 30 something. Yeah, but you can see and the other thing which I want to point, look at the needle and what happens. So it's not like a smooth transition. The needle jumps because of those irregular ball bearings. Here it's very visible. Tick, 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 left and right. Here it's kind of smooth, but you can see, right? I think when I go slow, it jumps a lot. You can see. Bum, 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 bum. All of those vibrations are being imprinted in this what you're milling. So your surface finish, maybe it's not terrible, but it's far from perfection as well. Okay, let's take a look. So it's, I'm gonna move it all the way in. Yep. And now I'm gonna pull it back. Watch the needle, right? You see the stuff is sliding, but it's not moving at all. Right? And that tiny movement, it's I guess me trying to pull it out and pull it in. I'm watching the screen now. But yeah, as you can see, there is nothing, and I can go slow so you can see if the needle is jumping, but there is no movement whatsoever as far as I can see. I think the dial indicator drifted a bit, but it's nothing related to imperfections or something. So here I have my granite straight edge with the Chinese rail and the backlight from my laser to see the light gaps in here, right? If it's straight or not. So that way it's quite okay. Just it's quite springy. Sideways. Okay. And the other side. Yeah. So here is quite a big bow. And as you can see, it's quite easy to bend it. Like you don't need much to straighten it up. And you have to straighten all of the rails when you're putting it on a machine. But that one is, you know, that place on the straightness, it's quite bad. But easy to correct. And now I'm gonna use the Bosch Rexroth rail and the bow from the bottom. It's quite dramatic. I'm gonna see here if it's as bad. Yep, it is. So that's the one which I'm gonna cut on half in here. And Well, let's see the straightness. Okay, that one it's straight. And then the other one, same problem. Quite a bow. At least it's consistent. It doesn't have, you know. And the side. Not as great as the other one, but oh yeah, that's a tiny amount, I have to say. I don't use much force to straighten it, so it has to be like, I don't know, a few microns, I guess. But that way, I have to hang on that thing, and it doesn't getting any straighter. So I'm afraid that when I'm gonna put that on my x-axis on the gantry, it's gonna bend the gantry, and even if it's a granite, it still does bend, especially if it's only, you know, 5 centimeters thick. So it's pretty much the thickness of the rail. Oh no, less. So the rail, I think it's the height of the rail, it's I don't know, 4 centimeters. Yeah, I'll be puzzled for a while, I guess. My plan for the gantry was to use roller guides, but with the size of 30, not 45, or 25 maybe, you know, something reasonable. But I got those from a guy in Australia. He has a shop on eBay under the Bullet Engineering. So take a look, he has some of them left, and he has also 55s, but that was just way too big. Yeah, I'm missing only the ball screws. I was planning to get ground ball screws, C3 precision. We'll see how that thing will go. At the moment, there is, you know, the coronavirus in China, so most of the factories are closed, and that particular one is closed. So I don't know, if you want to send me some precision ball screws, I will greatly appreciate. What else? I think that's gonna be all for today. I think it's gonna be quite a long video anyway. In the future episodes, I want to keep my build as detailed as this one is. So I'm gonna be explaining as much I can, or I remember to explain, about stuff I'm doing and why I'm doing it. So I hope you're gonna find it interesting, and I hope you learned something new, and see you next time.